So you've played games for your whole life. You mashed buttons, jumped over bits, and screamed at lag. But how does it actually work? How does pressing a button make your character leap or shoot? It's not magic. It's software. Every game runs on something called the main loop. It runs dozens or hundreds of times every second. Each loop handles your input, updates the game's logic, and then draws what you see on the screen. Press a button, the loop catches it, it changes the game state, then redraws the frame. This loop is the heartbeat of every game. When you press a key or move your joystick, the hardware sends a signal to your computer. The operating system picks it up, then the game engine listens for it during the next loop cycle. The input manager figures out what you want and tells the game what to do. It's just a function call somewhere in the code. Next comes the game's logic. This is where the rules live: health, damage, scoring, AI behavior, quests, and inventory. Every frame, the game asks: did the player take damage? Is the boss dead? Did the quest complete? Scripts written in languages like Lua, Python, or C Sharp decides all this. One tiny mistake and your player may have negative health or clip through walls. Enemy AI isn't smart. It's just a bunch of if-else statements. If you're close, they chase. If not, they wait or wonder. Sometimes they use line of sight or sound, but they don't think. They just react to what you do. Physics and collisions make games feel real. Objects have shapes and hitboxes. The physics engine handles stuff like speed, gravity, and impact. Jumping, falling, and explosions, it's all just math happening every frame. And if the physics mess up, you end up stuck in the floor or see stuff flying through walls. Rendering is how the game actually shows you everything on screen. The engine builds the scene from your camera view, hides whatever you can't see, and then sends the rest to the GPU, which uses shaders to decide how every pixel looks. So lighting, shadows, and reflections all get handled there. And that's why we have graphics settings, to stop your GPU from melting. Audio in games isn't just music. It's handling tons of sounds like footsteps, gunshots, and ambient noise, all placed in 3D space. The audio engine triggers these sounds, changes the volume based on how close you are, and mixes everything up so your ears doesn't file a noise complaint. Games are massive. Thousands of assets, models, textures, sounds, and scripts. But they can't load everything at once. So whenever you fast travel or get in a loading screen, it's just data being pulled in and out of memory behind the scenes. And that's where optimization comes in. Devs are always cutting corners, hiding what you can see, pulling objects, dropping detail at a distance, batching GPU calls, managing memory. Because one bad optimization, it can tank your frames or straight up break the game. Performance is crucial for single player games, but when you add multiplayer, things get even more complicated. Multiplayer games rely on code that connects all players in real time. It sends your actions to others, processes their inputs, and keeps everything synchronized. It manages lag and prevents exploits. Everything runs on a game engine: Unity, Unreal, Godot, or something custom. The engine handles low level systems: rendering, physics, input handling, audio playback, animations, asset streaming, scene graphs, and memory management. It gives developers a framework to build on so they focus on gameplay, logic, and content, while the engine handles the core architecture that makes everything run consistently across devices. That's how games work: code, logic, maths, visuals, audio, networking, all working together in real time. And it's just beautiful. If you found this interesting, hit subscribe to see more. Got questions or topics you want me to break down? Drop them in the comments. I read every one of them. Thank you for watching. Bye bye.